Hello, Gabriel. Can you hear me? Good. Gabriel, nice to meet you one more time. So we are again together here. Even I cannot see your face, but I hope you can see me and you're there. So we were talking about linear equations. These actual equations are simple, but it has a lot of applications. And also in the future, when you go to university, when you take linear algebra class, you will see a wide range of its applications. So last time in our last week class, we talked about how to solve linear equations, right? What is a linear equation and how do you solve this? And also we considered linear equations with coefficients where the coefficients are variables or parameters or simply letters. Okay, so now today we will discuss about system of linear equations or a simple system of linear equations. That means that we are given maybe 2 or 3 or 4 in general. In the future we'll see that n linear equations and how do we solve them. And of course here we are not going to consider general case, we're just going to consider the systems which consist of 2 or 3 equations. And some are actually at the beginning you will see that they are not linear, but they are reducible to linear equations. And again, linear equations means that we have to bring into the form like ax is equal to b or ax plus by is equal to c, something like this. So usually when we are solving system of linear equations, we have 3 commonly used methods. The first one is elimination method. Second one is substitution method. Third one is graphical method. Of course, this graphical method, maybe if you have 2 or 3 equations, is fine. But if you have more than that, it does not work at all. So actually, the most commonly used method is in solving system of linear equations. It is elimination method, or sometimes we call this Gaussian elimination method because it was discovered or actually the first time Gauss, the German mathematician, he actually suggested this method and it's really practical and easy to use. So system of linear equations or simultaneous linear equations is an important tool to solve many practical problems. Many practical problems, again, is related to maybe what is it, flow of traffic or flow of water or some linear dynamic systems, or it's also used in chemistry reaction problems or biology problems. It has a lot of applications, but here, okay, we are going to learn how to solve the systems, and later maybe we can talk about their application. So for example, if you look at this example, right, here we have x plus 2y, here we have x plus 2y is equal to 3. As you see, x plus 2y is equal to 3 is a linear equation in 2 variables. X is the first variable, y is the second variable. And the second equation, 3x minus y equals -5. Also, actually, it is a linear equation in 2 variables. Once again, why am I saying that these equations are linear? Because all variables are multiplied by a constant number. In the equation, we do not have a product of 2 variables. Like we don't have like x times x or x times y or y times y. We don't have such terms. Okay, that's why it's called linear equation. So if you look at each one, for example, consider separately, right? And for example, x plus 2y equals 3, it has infinitely many solutions. Why? Because its graph is a straight line. Every point on the straight line gives us one solution to this equation. But again, when we talk about the system of linear equations, we need to find a pair of numbers here so that it satisfies both equations simultaneously. And that's why it's called simultaneous linear equations. So if there is a common solution for all of the equations here, it is called the solution of the system. Now here we will study how to find the solution of such systems. So similar to linear equations, a system of linear equations may have 1 or 0 or infinitely many solutions. Okay, that's really, actually, it's a theorem in math. It means that if you're given a number of or a system of linear equations, the system has 0 solution, or only one solution, or infinitely many solutions. For if we are considering that our variables are any real number. So we don't have this case that the system has maybe 2 solutions or 5 solutions. We don't have this case. Either it has 0 solution, it means no solution, or only one solution, or infinitely many solutions. And again, we have already talked that the basic idea or the most important or most commonly used method to solve system of linear equations is elimination method or elimination of variables. Okay, let's see one example immediately. For example, here, if you're given this system, right? So using, okay, in 2 different ways, let me just immediately show both ways here, the first method, the second method, okay? The first one is elimination method. Second one is substitution method. Substitution method. Okay. In elimination method, actually, we have to eliminate one of the variables, and we just obtain one equation in one variable. So if I do so here, what should I do here? How can I eliminate? Let me eliminate y. How can I eliminate y? To eliminate y, they need to have the same coefficients, and either I subtract or add these 2 equations. So the first one is x plus 2y is equal to 3. And here we have 3x minus y is equal to -5. Okay, so instead of writing this one, how about if I multiply the second equation by 2? Right? If I multiply both sides by 2, because if you multiply by a constant number, it does not change the solution. 2 times 3x, it is 6x. 2 times -y, it is 2y. 2 times -5, it is -10. So now see here, the coefficients, right? Actually, the numerical values may be the same, but opposite sides. So now how can I eliminate y? Let me add the first equation to the second one. X plus 6x, that's equal to 7x. And that's equal to 3 plus -10, that's equal to -7. So 7 times what number is -7? From here, x equals -1. So we have the first, actually, the value of x. Now, if I substitute this value into the first or the second equation, we will get the value of y. And of course, we need to have a look. And which actually equation looks simpler, right, for evaluation. As here, the first one looks simpler. So let me just substitute into the first one. So here we have x equals -1 plus 2 times y is equal to 3. Take -y to the right-hand side, and 2y is equal to 3 plus 1. It is 4. So y is equal to 2. Now, dot, 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 we can write the solution of this system. What is it? It is -1 and 2. Okay. And by solving using this method, we call this elimination, because we are eliminating one of the variables. If we have 3 equations and 3 variables, step by step, we eliminate the variables and bring them into an equation in one variable. And solve this, again, by backward substitution, we can obtain other solutions of this equation. How about part B, substitution? In substitution, we have to express either y in terms of x or x in terms of y. But here, for example, let me express y in terms of x in the first equation. And if you just take y to the right-hand side, -1 to the left-hand side, what is y here? Y is equal to 3x plus 5. Now I'm going to substitute this into the first equation. Then here we have x plus 2 times y. What is y? Y is 3x plus 5 is equal to 3. Now we have one equation and linear equation in one variable. We know how to solve this from the previous class. Here we have x, 2 times 3x, it is 6x, 2 times 5, it is 10. On the right-hand side, we have 3. X plus 6x, that is 7x. Take 10 to the right-hand side, 3 minus 10, that is -7. So from here, x equals -1. Okay, that's the first step. So now I know the value of x. So now we can get the value of y. Substitute into the first or the second equation. Now we have this, why we know how actually y is related to x or connected to x. So substitute into that equation. Here we have 3 times what is x? X is -1 plus 5. That's equal to 3 times -1. -3 plus 5, that is 2. So dot, dot, dot. The solution of the system, it's a pair of numbers, right? So that is -1 and 2. It has one solution. So x equals -1 and y equals 2. That's the solution of this system. Okay. So another example, solve the system. Okay, solution. So here, and either using a substitution method or elimination method, you can solve this. Again, let's just use elimination method, okay? Usually substitution method we use in what case? If one equation is linear, another equation is non-linear. Okay, at the time, this elimination method does not work. At the time, substitution works. But here, for system of linear equations, elimination is one of the, let's say, very commonly used method. So again, to solve this one by elimination method, I'm going to multiply the first equation, both sides by 4, the second equation, both sides by 3. If you multiply the first equation, I mean both sides of the first equation by 4, 4 times 4, here we have 16x, plus 4 times 3, here we have 12y, 4 times 26, 80, 24, that's equal to 104. And if you multiply the second equation by 3, 3 times 5, it is 15x. So here we have 15x minus 12y. On the right-hand side, we have 51, right? So see here, I can eliminate y's here. Now draw a line, and because coefficients actually they have opposite signs, so I'm going to add the first equation to the second equation. This is our first equation, and this is our second equation. So if you add them, 16x plus 15x, that's equal to 31x. 12 plus -12, that's equal to 0. 104 plus 51, that's equal to 155. So from here, what is x? X equals 155 over 31, which is equal to 5. So now we got the value of x. The next thing is I have to find the value of y. I need to substitute the value of x into the first or the second equation. Again, have a look. Which equation looks simpler to calculate? Let me calculate. Actually, both look simple. So I'm going to substitute this value into the first equation. So here we have 4 times 5 plus 3 times y is equal to 26. Now from here, 3y is equal to 26 minus 20, that's equal to 6. Y is equal to 2. So dot, 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 the solution of this equation, then it is 5 and 2. Of course, always you need to write the solution in alphabetical order, right? If the variables are a and b, first a, then b. If it is x and y, then first x and y. If it is x, y, z, first x, then y, it is z. This is just by convention. Okay, in math, we actually write in alphabetical order. Okay, example 3. How about if you're given 3 equations? Okay, again, I'm going to use the similar idea, all right, elimination. Using these 2 equations, I can eliminate z. Using these 2 equations, I can eliminate z. Then I will have 2 equations, but in 2 variables. Using the previous method, again, we are going to eliminate y. Then we'll have 1 equation in x. So after finding the value of x by back substitution, I can find the value of y, and I can find the value of z. So solution, so already as see here in the first, that's our first equation, and this our second equation, and this our third equation. In the first and second equation, actually the coefficients of z, it is 1 and -1. If I just add them together, right, I can eliminate z. So if you add the first equation to the second equation, x plus 3x, that is 4x, and y plus 2y, that is 3y. And z plus -z, that's equal to 0. 6 plus 4, that's equal to 10. And how about actually second and third equation? And third equation, the coefficient of z is 2. The first one, it is, what is it, -1. So to do this one, first, I will multiply the second equation by 2. I mean, both sides of the second equation by 2. At the time here, we have 6x plus 4y minus 2z is equal to 2 times 4, that's equal to 8. So now if I add this, here we have x minus 3y plus 2z is equal to 1. If you add them together, 6x plus x, that is 7x, 4y plus -3y, that is plus y, and -2z plus 2z, that's equal to 0, 8 plus 1, that's equal to 7. Now we have two equations in two variables. Also, we can simplify them, right? So let me just multiply both sides of the second equation by 3 so that y variable will have, or variables will have the same coefficients. So let me just rewrite the first equation for x plus 3y is equal to 10. In the second equation, multiply both sides by 3. So 3 times 7, 21x, 3 times y, 3y, and 3 times 7, that is 21. So now they have the same coefficients, right? So I need to subtract. Let me subtract the first equation from the second one. 21 minus 4, that is 17x. 3y minus 3y, that's equal to 0. 21 minus 10, that's equal to 11. A plus 1, it should be 9. Sorry, here it should be 9, right? Because I added 9. So multiply by 3, 27. 27. So subtract here, 27 minus 10, it is 17. So from here, what is x? X equals 1. So that is a value of x. So now if I substitute this into these equations, right? Let's say this equation number 4, and this one is number 5. Into the 4, I will get the value of 1. So let me just change the color here. That's our first step. In the second step, here we have 4 times in equation 4. What is x is equal to 1 plus 3 times y is equal to 10. So from here, 3y is equal to 10 minus 4, that's equal to 6. What is y? Y is equal to 2 because 3 times 6 is equal to 6. Now also we have the value of y. So now if I substitute this into the first equation, we will get the value of z. So x sub 3, so x plus y plus z is equal to 6. What is x? X equals 1. And what is y is equal to 2. And here we have z, that's equal to 6. Now from here, z is equal to 3. So dot, dot, dot. Now we can write the solution. X equals 1, y is equal to 2, and z is equal to 3. These are the solutions of this system. Gabriel, is everything okay? Good. Then let's continue that. All right. Assumption of equal ratio. Now, sometimes, of course, systems are given in different ways. Actually, the ideas are similar. If some equal ratio is given, we can let them be a constant k and then find a way for substitutions. So in this example, for example, as you see, what is it given here? Here, actually, the first one, the ratios of x and y and z are given, right? This x over 2 equals y over 3 equals z over 5. What does it mean? It means that the ratio of x to y to z is equal to 2 to 3 to 5. And this is how they are related to each other. So now if I just introduce one thing here, solution. Okay, suppose that this x over 2 is equal to y over 3 is equal to z over 5. Let's say is equal to some constant k. Now from here, we can express everything in terms of k, right? What is x here? X is take 2 to the right-hand side, that is 2 times k. What is y? Y is equal to 3 times k. And z is equal to 5 times k. Now using this actual substitutions, if I substitute them into the second equation, and this is our first equation, and this is our second equation, we will have an equation in only one variable, linear equation. So 5 times, what is x? X equals 2k. 4 times, what is y? It is 3k. 3 times z, it is 5k, is equal to 259. 5 times 2, it is 10k. 4 times 3, it is 12k. 3 times 5, it is 15k. 259. 10 plus 12, 22. So 22 plus 15 is 37. So here we have 37k is equal to 259. So from here, k is equal to 259 over 37, which is equal to, if it is 10, it's around 70, it is 7, right? 210 and 49, so that is 7. Okay, 7 times 37 is equal to 259. So I know the value of k here. So now from here we can find the values of x, y, z. So what is x? X equals 2 times k. 2 times 7, that is 14. And what is y? Y is 3 times k. 3 times 7, that is 21. And z is 5 times k. 5 times 7, that is 35. So these are the solutions of the given system. So maybe I can just write it dot, dot, dot. X equals 14, y is equal to 21, and z is equal to 35. Okay. Substitution by whole. This also just to give you idea. Okay, sometimes we can just substitute the whole thing into the equation. Now if you look at this system, for example, 17x plus 21y is equal to -1. And the second one, 5x plus what is this, 7y is equal to 3. And this first equation, this first equation, how can I write this? Because this 5x, 3y, if you multiply both sides by 3, here we have 15x plus 21y is equal to 9, right? So this 15x, I can just write it as 2x and plus 15x plus 21y. On the right-hand side, we have -1. Now, let me just rewrite this. Here, 15x and 21y. What is the common factor? It is 3. So that is 3. And so here we have 5x plus 7y is equal to -1. Now 5x plus 7y, our just second equation, right? That's equal to 3. So now that's why we are saying the substitution by whole. So that is 2x plus 3 times 3. It is 3 times 3 is equal to -9. So 2x equals, take 9 to the right-hand side, -1 minus 9 is -10. So dot, 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 x is equal to -5. So now if you know the value of x, substitute into the second one, we can find the value of y. Here we have 5 times x. X equals -5 plus 7 times y is equal to 3. So here we have 7y equals 3, -25, right? Take to the right-hand side, it is positive 25. 3 plus 25, that's equal to 28. So what number times 7 equals 28? That is 4. So now we can write the solution of the system. So that's x equals -5 and y is equal to 4. That is the solution of this system. It's also just another idea. Sometimes if you just can see that, I can see the whole equation, maybe the second equation, we can just use it or can substitute into the first equation. I'll just speed up our procedure so we can reach the solution much faster. All right, method of summation. How in this question, for the system having a symmetric structure, we may sum the equations up and compare the result with original equations. Now here, 3x plus y plus z, 2x plus 4y plus 2z, and 3x plus 3y plus 5c is equal to, what is this? Is 12. So now, if you just add them together, what happens here is 3 plus 2 plus 3, it is 8. 1 plus 4 plus 3, also it is 8. 1 plus 2 plus 5, also it is 8. So actually, this also, it's not a new method, okay? Without doing this also, we can calculate this. Again, we can just do this maybe in a faster way. For example, here, if you just add them together, let me just continue here. 3x plus 2x plus 3x, I'm just adding all of these equations together. So here we have 8x, y plus 4y plus 3y is also 8y, 1z plus 2z plus 5z, also it is 8y, 8z. On the right hand side, negative 2 plus 6, 4, 4 plus 12, that's equal to 16. Now, if you divide both sides by 8, so here we have x plus y plus z is equal to 2. So now, how am I going to use this? As see here, for example, this first one, if I just substitute into the first equation, right? I know what is y plus c. What is y plus c? 2 minus x, right? So I can find the value of x. And after that, if I just substitute this, the second one and the first and second equation, we will have just yz and also yz, and we will get the value of y and the value of z. Anyway, from here, y plus z is equal to 2 minus x. Let me substitute into the first equation. Here we have first step. Actually, this is our first step. Let me just write here, this one is our second. Second step, the first equation, 3x plus, what is y? Or like even I can just write it like this, 3x plus y plus z, right? I can just write it as 2x plus x plus y plus z. On the right hand side, we have negative 2. And even I don't have to write this. What is this x plus y plus z? That's equal to 2, right? So here we have 2x plus 2 is equal to negative 2. Or 2x equals, take 2 to the right hand side, negative 2 minus 2, that is negative 4. So x equals negative 4 over 2, that's equal to negative 2. So now we know the value of x here. Okay. And the third one, second one, for example, here we have 2x, 2y, 2z, right? This 4y, I can just write it as 2y plus 2y. So I can just write it as 2x plus 2y plus 2y plus 2z is equal to 6. So now 2x, 2y, 2z. What's the common factor? 2. Take this 2 out. Here we have x plus y plus z. And here we have 2y also. That's equal to 6. And x plus y plus z, that's equal to 2. Substitute here. 2 times 2 plus 2y. That's equal to 6. Now, if you just solve for y, takes 4 to the right hand side. 6 minus 4, it is 2. Divide both sides by 2. So that's equal to 1. So now if I just substitute in the last equation, right, we can get the value of y, I mean z. Just change the color here. Number 4, x equals negative 2. Y is equal to 1. And here we have z. On the right hand side, we have 2. Now from here, z is equal to a negative 2 plus 1, negative 1. Take to the right hand side, that's equal to 3. So now dot, dot, dot. X equals negative 2, y is equal to 1, and z is equal to 3. Okay. Another problem, a little bit different, but still, again, we are going to use the same idea. So change of variables, or sometimes we just use this, what is that, using auxiliary variable. So it's a method by changing complicated algebraic expression into another to simplify calculation. That's also a very commonly used method. So we have to introduce new variable or new parameter. All right. Let's say here we have 1 over a plus b, 1 over a plus b, 1 over b plus c, 1 over b plus c, 1 over c plus a, 1 over c plus a, right? So now if I just introduce these new things, let me just write here that x is equal to 1 over a plus b, and y is equal to 1 over b plus c, and z is equal to 1 over c plus a. At the time, what we have here? Here we have this equation, right? Here we have x plus y is equal to 12 over 35. The second one is y plus z is equal to 13 over 42. The last one is z plus x is equal to 11 over 30. Also a variable, just call this sometimes variable. Okay, so now again using the previous method, if I just add them all together, what happens here? If you add them together, x plus y, y plus z, z plus x, right? We have 2x, 2y, 2z. So here we have this thing. Here we have 2 times x plus y plus z. On the right hand side, here we have 12 over 35 and 13 over 42 plus 11 over 30, right? Or if you just simplify this, if you simplify this, here we have 12 over 35 plus 13 okay, 35 plus 13 over 42 plus 11 over 30. So if you just simplify this, here we get, what is it, 107 over 105, 105. Okay, because common denominator 35 and 42, it's actually 210. After we can just simplify this. So now if you just multiply both sides by 1 over 2, I will just get the thing. Let me just continue here. So here we have x plus y plus z is equal to, what is it, 107 over 105. I'm multiplying both sides by 1 over 2. So here we have 107 over 210. So that's our equation. So now step by step, we can determine others. Now, if you look at the first equation, what is the first equation? That's our first equation, and this is our second equation, and this is our third equation. X plus y equals 12 over 35, right? So here we have x plus y equals 12 over 35. So that's our first equation. So now if I just subtract, right, the first equation from, the second equation from the first one, x minus x, 0, y minus y, 0, and z. Here we have z. On the right hand side, we have 107 over 210 minus 12 over 35. So which is equal to, common denominator is 210. And here we have 107 minus, I need to multiply this by 6 because 6 times 35 is 210. That is 72. So which is equal to, let me just write here, dot, 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 z is equal to, it is 28 plus 7, that is 35 over 210. Or we can divide them, simplify this. Both numerator and denominator is divisible by 7. 35 is divided by 7, that is 5. And this one is divided by 7. Actually, it's just 1 over 6, right? Because 6 times 35 is equals 210. It's just equal to 1 over 6. So that's the value of z. Okay, so now we'll continue. How about the value of y? To find the value of y, let me just write the last equation, z plus x equals 11 over 30. So now here we have z plus x is equal to 11 over 30. So here we have 11 over 30. And our equation here is x plus y plus z equals 107 over 210. Again, if you subtract the first equation from the second one, right? X, it's gone. Z, it's gone. What is left here? It is y. On the right-hand side, 107 over 210 minus 11 over 30. Common denominator is 210. Here we have 107 minus multiplied by 7. So here we have 77. So from here, y is equal to, it is 30 over 210. That's equal to 1 over 7. Okay. So now if you just continue in this way, so that is, let's say this part is the first step. This was our first step, and this is our second step, and this is our third step, and this one is fourth step. And the last step is we need to find the value of x. How can I find the value of x? Just substitute into this equation. X plus, we know y, that is 1 over 7, plus we know z, that's equal to 1 over 6. On the right-hand side, 107 over 210. So what is x? X equals 107 over 210 minus this 1 over 7 plus 1 over 6, that's equal to 13 over 42. So that's equal to 13 over 42. Now common denominator is 210. Here we have 107 minus 5 times 13, that's equal to 65, which is equal to 35 plus 7, that is 42 over 210. If you simplify by 42, that's equal to 1 over 5. So now dot, x equals 1 over 5, y is equal to 1 over 7, and z is equal to 1 over 6. Okay, so of course here we need to find the value of a plus b plus c, right? So actually here it is, we have x. Okay, so we are going to find it. So here equals. What is x? X equals 1 over 5. So this one equals 1 over 5. And y is equal to 1. And x equals 1 over 5. Y equals 1 over 7. 1 over 7. And z is equal to 1 over 6. Okay, 1 over 6. Okay. So now from here, right, you see here, a plus b equals 7. So I'm just going to finish here. All right, just open here. Let's try to finish here. So from here, what is a plus b? A plus b is equal to 5, right? The second one, b plus c is equal to 7. And a plus c, the third one, or c plus a, is equal to 6. Again, if we just add them together and divide by 2, here we have a plus b plus c is equal to 5 plus 7, 12, 12 plus 6, 18. And on the right-hand side, we have 2a, 2b, 2c. 18 is divided by 2, that's equal to 9. Okay, so since AB is equal to 5, what is C? C is equal to 4. BC is equal to 7. What is A? A is equal to 2. AC is equal to 6. What is B? B is equal to 3. So now dot, final answer is A is equal to 2, B is equal to 3, and C is equal to 4. That is the solution of the system. Okay. Gabriel, that's it that we have to learn in this class. Now we have some questions in exercise 2. Now, if I try to solve all the questions, also it may be a bit boring for you, but let's just pick a few questions and do them, okay? Like, for example, in question 1, we have how many? A, B, C, D, E, F. So let me just solve only 3 of them from here. So now I assume that you have some idea how to solve system of linear equations. I will go a little bit faster. Just a minute. Okay, solve the following system of linear equations by method of substitution. So let's start with the first one. Substitution, already y is given, y is equal to x, so we have the substitute in the second equation. So if you substitute in the second equation, what is y equals x? So x plus, 4x is equal to 15. X plus 4x is 5x. So what is x? X is equal to 3. If x equals 3, since y is equal to x, also y is equal to 3. That is a solution. And how about question E? Let's do question E. In question E, by substitution method, okay, let me express y in terms of x using the first equation. Take y to the right-hand side, 27 to the left-hand side. So y is equal to 3x minus 27. Now substitute into the first equation. So here we have 2 times y. What is y? Y is 3x minus 27. Minus 3x minus 3x is equal to 0. So now if you expand this and simplify this, 2 times 3x, 6x minus 3x, that is 3x. And 2 times negative 27, it is negative 54. Take to the right-hand side, it is positive 54. So from here, what is x? 54 is divided by 3, that is 18. So if x is equal to 18, then y is equal to 3 times 18 minus 27. That's equal to, what is that? 54 minus 27, that's equal to 27. So x equals 18 and y is equal to 27. Question F, solution. And see here we have actually 2 equal signs here. So here we have 1, and here we have 2. What does it mean? It means it's something like that. Let me just go on the left-hand side. A is equal to B is equal to C. So that means that actually, how can I form 2 systems? I can just write here A equals B and B is equal to C. I can form like this. Or A is equal to C and A is equal to B. Also, this is also true. Or A is equal to B and B is equal to C. Actually, it doesn't matter, all right? Or you can just even write A equals B, A equals C, B equals C. But you will say that to solve this system, just 2 equations enough. So let me just pick the first and the second equation. So here we have 5 minus x minus 2y is equal to, here we have negative 2, right? So I'm just going to use 1. This a is equal to c. What is c? Here it is negative 2. So that's equal to negative 2. And also here we have 7x plus 5y plus 3 is equal to negative 2. Because they are all equal to each other, it doesn't matter which 2 equations I pick. So here, first one, if you just take this 5 to the right-hand side, so here we have minus x minus 2y equals negative 2 minus 5, that is negative 7. The second one, here we have 7x plus 5y is equal to, takes it to the right-hand side, negative 2 minus 3, that's equal to negative 5. So now I have to, for example, let's say, here, it's easy to eliminate x, right? Let me just multiply the first equation. I mean, both sides of the first equation by 7. If you multiply by 7, here we have minus 7x minus 14y. 7 times negative 7, that is minus 49. The second equation just by itself, 7x plus 5y equals negative 5. So now if you add them together, so negative 7 plus 7, that's equal to 0. Negative 14 plus 5, that is minus 9y. Negative 49 plus negative 5, that is negative 54. From here, what is y? Negative 54 is divided by negative 9, that's equal to 6. So now we got the value of y. Now if I substitute into the first equation, we will get the value of x, right? So that is, or let's say the first step, in the second step. So here, negative x minus 2 times y. What is y? It is 6. On the right-hand side, we have negative 7. So negative x equals 2 times 6, it is negative 12. Take to the right hand side, negative 7 plus 12, that's equal to 5. So from here, x equals negative 5. So dot, 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 the solution of the system is negative 5 and y is equal to 6. So that is the solution. Question 2, solve the following system of linear equations by method of elimination. So let me just do only B here. Okay, why it's not. All right, 9x minus 4y equals minus 56. 3x minus 4y is equal to 40, right? So we have to eliminate one of the variables. It's already the coefficients are the same, right? The coefficients of y, let's just add them together. Add the first equation, subtract the first equation from the second one, or the second one from the first one. So 9x minus 3x, that's equal to 6x, negative 4 minus negative 4, that's equal to 0, minus 56 minus 40, that is minus 96. So from here, x equals minus 96 over 6, that is minus 16, the first step. Now in the second step, so we have to substitute this into maybe the first or the second equation and get the value of y. Let me substitute into the second equation. Here we have 3 times minus 16 minus 4 times y. On the right hand side, we have 40. Take 4y, negative 4y to the right hand side and 40 to the left hand side. So here we have 4y is equal to 3 times minus 16, that is minus 48, and minus 40, which is equal to minus 88. So from here, what is y? Y equals minus 88 is divided by 4, that is minus 22. So dot, 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 x equals negative 16, and y is equal to negative 22. So these are the solutions of this system. Another example, which one? Let's do question C. Also here we have, okay, from each page, let's just do only one. So let's do C here. C first, negative 5, right? Let me just take to the right hand side. And here we have 10x plus 12y is equal to negative 1. And here we have 9x minus 4y is equal to 5. So which one is easy to eliminate? I think it is y. Let me just multiply the second equation by, 3. So at the same time, if I just multiply by 3, 3 times 9, it is 27. 3 times 4, it is 12. 3 times 5, it is 15. So now if I just add these two equations, because the coefficients have opposite signs, 10 plus 27, that is 37x. 12 plus negative 12, that's equal to 0. Negative 1 plus 15, that's equal to 14. Okay, so from here, x is equal to 14 over 37. That's a fraction, so what can we do? Nothing. So that's our first step. The second step, we need to find the value of y, right? So which one? Let me just substitute into the first equation. So here we have 10 times x. What is x? X is 14 over 37 plus 12y. On the right-hand side, we have negative 1. Let's say take this to the right-hand side. So here we have 12y equals negative 1 minus 10 times 14, 140 over 37. Which is equal to 37, right? It is minus 177 over 37. So now 177 is not divisible by, so what is it? It is 3, 8, 15. Okay, this is divisible by 3. So from here, what is y? Y is equal to minus 177 over 12 times 37. So now if you just simplify by, what is it, 3, so that is 177 over 12 times 37. That's equal to, because by 3 we can simplify this, why by 3 it is 59. So that's equal to minus 59 over, here we have 4 times 37, 144. So the solution is x equals 14 over 37 and y is equal to minus 59 over 144. Sometimes we may have this kind of fraction solutions is also fine, especially applied problems or in applications. A lot of numbers are not so beautiful number. I mean, not whole numbers at all. Anyway, another example. How about question F? Let me just write here solution. Again, actually, it's just given as a single equation, but it has two equal signs. So I'm just going to write it as two equations. How? The first one is 5x equals 2x minus 2y plus 13. Or the second one is, let's say this 5x equals 3y plus 9. Okay, it's up to you how you choose this, because choosing 5x is just simpler, right? It's only one term, so I'm using 5x to equate with other parts of the equation. So now if you simplify the first one, take everything to the left-hand side, 5x minus 2x, that is 3x, and negative 2y, changing the sign, it becomes 2, positive 2y on the right-hand side, so we have 13. The second one is 5x minus 3y is equal to 9. Right. So I will multiply the first equation by 3, the second equation by 2. And after that, we will add them together. Let me first multiply them, carry out this multiplication. Multiply both sides of the first equation by 3. 3 times 3 is 9x plus 6y. 3 times 13, that is 39. And the second one multiplied by 2, it is 10x minus 6y is equal to 18. So now if we add them together, 9 plus 10, it is 19x, 39 plus 18, 40, it is 57. So what is x? X is equal to 3, because 3 times 59 equals 57. So now if you substitute, let's say it's our first step, right? In our second step, substitute into the second equation. So that is 5 times 3. On the right-hand side, 3y plus 9. So from here, what is 3y? 3y equals 15 minus 9, that's equal to 6. So y is equal to 2. So dot, x is equal to 3, and y is equal to 2. Gabriel, are you okay? Gabriel, why you never talk? No? Are you shy, or you already know everything here, that's why you are quiet, or why? Okay, if you prefer, if everything is okay, if you have any questions, just let me know. Okay, so now let's continue then. I see. All right, good. Question 3, solve the system. So solution, let's just from here. Again, now you know the ideas. So we're going to eliminate first in the first step the variable z, in the second step variable y. So we have equation x, find the value of x, after that find the value of y and z. That's it. So first, actually to eliminate, what is it? From the first and second equation, this is our first equation, and it's our second equation, it's our third equation. Okay, so I need to eliminate z. How can I eliminate z? Okay, first, if I multiply the third equation by 3 and add it to the first one. Okay, let me just do this mentally. So multiply this one, actually equation 3 by 3, okay, and add to the first one. 3 times 2x, it is 6x plus x, that is 7x. And minus 3 times 3 times minus 9 plus minus 2 minus 11y. And minus 3z plus 3z, that's equal to 0. 3 times minus 11 and minus 33 plus minus 1, that is minus 34. In the second case, I will multiply the third equation by 5 and add it to the second equation. 5 times 2, 10. 10 plus 3, it is 13x. And 5 times 3 minus 15 plus 2, that is minus 13y. And minus 5z plus 5z is equal to 0. Minus 5 times minus 11 minus 55 plus 29, that's equal to, what is it? 25, 26, that is minus 26, right? Because you're just adding this, minus 55 plus 29, that's equal to minus 26. So that's it. So now we have to eliminate y's. So this 11 and 13, these are what is it? Prime numbers, actually relatively prime numbers. The only common factor is 1. So the only way is I have to multiply the first equation by 13 and second one by 11. So 7 times 13, that's equal to 91x minus 13 times 11. I can just write it as 11 times 13y. And here we have 13 times minus 34. Let's take one multiply by 11. 13 times 11, 130, 143, 143x minus 11 times 13y. On the right-hand side, minus 26 times 11. Also, this one I should write it as minus 34 times 13. So now if we just subtract, right, the first equation from the second one, 143 minus 91. So that's equal to, what is it? 43 and 9. So that is 52x. And these coefficients the same, right? Minus 11, 13, minus 11, 13, that's equal to 0. And how about minus 26? Minus 26 times 11. And actually, we are subtracting this is plus 34 times 13. 34 times 13. So that's equal to 156. So now from here, what is x? X equals 156 over 52. That's equal to 3. So now we got the value of x. Okay. All right. So now if you know the value of x, I can find the value of y and substitute into this equation, right? So that's our first step. And in the second step, we can find the value of y. So that is 7. Let me just change the color here. Here we have 7 times x. X equals 3 minus 11y. On the right-hand side, minus 34. So minus 11y is equal to minus 34 minus 21. What is y? Y is minus 55 minus 55 over minus 11. That's equal to 5. And also that is the value of y. So now if I just substitute into the first equation, we will get the value of z. So the first equation, so x, we know x equals 3 minus 2 times y. What is y? It is 5 plus 3z. On the right-hand side, we have negative 1. So 3z equals 3 minus 10, negative 7. Take to the right-hand side, minus 1, right? So that's minus 1 plus, because it is minus 7, so it is 7, which is equal to 6. So z is equal to 2. So now dot, 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 x equals 3, and y is equal to 5, and z is equal to 2. That's how we solve the system of linear equations. So another one, okay, let me just skip this. This was a similar question. Okay, so it is 3y, okay, 6y, okay, let's say, well, I will skip this. Let's just do question 5. We are running out of time. Solution. So here we have x to y to z is equal to 1 to 3 to 5. So what does it mean by ratio? If you know that since the ratio of x to y to z is equal to 1 to 3 to 5, that means that x is equal to k, 1k. So y is equal to 3k, and z is equal to 5k. So now we have to substitute into the second equation. What is x? So x is equal to k. Y is equal to 3k, and z is equal to 5k. On the right-hand side, we have 24. K minus 3k, actually the 6k minus 3k, that's equal to 3k. On the right-hand side, we have 24. Now what is k? K is equal to 8. So now we can write the solution of the system, dot, dot, dot. X is equal to k, that is 8. Y is equal to 3 times k, that is 24. And z is equal to 5 times k, that's equal to 40. So that's the solution of this system. All right. So the system, so we did a lot of examples similar to this, so I'm going to skip this. So, okay. So question 7. Now, if you just have a look at this question, if you just add all of this equation, what happens here? X plus x minus x, that's equal to x. Y minus y plus y, that's equal to y. Minus z plus z plus z, that's equal to z, right? So we are just going to use the symmetry property. Here we have, if you just add them all together, add equation 1 and equation 2, equation 3. X plus x minus x, that's equal to x. Y minus y plus y, that's equal to y, and minus z plus z plus z, that's equal to z. On the right hand side, 1 minus 3 minus 2 minus 2 plus 5, that's equal to 3. Okay, so now from the first equation, x plus y minus z, right? So let me just write the first one after adding this. So the first equation is, what is it? X plus y minus z is equal to 1. So if you subtract, what happens here? X minus x, 0, y minus y, 0, z minus minus z, that's equal to 2z. 3 minus 1, that's equal to 2. So what is z? Z is equal to 1. Okay. And the second step is, again, let me just write here, x plus y plus z is equal to 3. Write the second equation, x minus y plus z is equal to minus 3. So now again, if we subtract, so x minus x, 0, y minus y is equal to 2y, z minus z equals 0, 3 minus minus 3, that's equal to 6. So from here, y is equal to 3. And since x plus y plus is equal to 3, and so x is equal to, we don't know, y is equal to 3, z is equal to 1. On the right hand side, we have 3. Now what is x from here? X equals negative 1. So now dot, 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 x equals negative 1, y is equal to 3, and z is equal to 1. That's the solution of this system. Okay. Another example here, if you remember, how did we solve this kind of questions? Even without this, we can do this, but let me just use that method. Okay, let me introduce new variable here. 1 over a plus b, let's say, is equal to x, and 1 over b plus c, that's equal to, let's say, this y, and 1 over c plus a, that's equal to z. At the time, then this equation becomes, what is it? X plus y is equal to 3 over 2. And y plus z equals 6 over 5. And the z plus x, right? Because 1 over c plus a is c, 1 over a plus b is x. So that's equal to 7 over 10. Okay. Now, after this, let's continue here. If we just add them all together, right? X plus y plus z. So here we have 2 times x plus y plus z. On the right-hand side, we have 3 over 2 plus 6 over 5 plus 7 over 10. So what is it? It is 3 over 2 plus 6 over 5 plus 7 over 10. So that's equal to 17 over 5. So from here, x plus y plus z is equal to 17 over 5. Multiply both sides by 1 over 2. That is 17 over 10. So that's how we actually obtain this x plus y plus z. Now from here, as you see, x plus y equals 3 over 2, right? If you just substitute there, here we have continue, that says 1, and this one is 2. X plus y plus z is equal to 17 over 10. And the first one is x plus y is equal to 3 over 2. So if you subtract, right, x gone, y gone, so here we have z. And what is 17 over 10? 17 over 10 minus 3 over 2. That's equal to 1 over 5. That's equal to 1 over 5. In a similar way, so here we have x plus y. Let me just change the color here. 3. Here we have x plus y plus z. Again, that's equal to 17 over 10. The second one is y plus z is equal to 6 over 5. Now, if you subtract, right, the second equation from the first one, y is gone, z is gone. So here x. So here we have 17 over 10 minus 6 over 5, which is equal to common denominator is 10. 15 minus 12, that's equal to 5. That's equal to 1 over 2. And in similar way, number 4. So here we have x plus y. Use here x plus y plus z is equal to 17 over 10. And the last equation is, what is it? X plus z is equal to 7 over 10. Again, if you subtract x is gone, x is gone, y is gone. Here we have y is equal to 17 over 10, 17 over 10 minus 7 over 10, 7 over 10. That's equal to 70 over 10, 7 over 10, that's equal to just 1. Okay, so now from here, we can just write, what is it? From here, so this x is equal to, what is x? X is equal to 1 over 2. Y is equal to 1, and z is equal to 1 over 5. So which means that here we have a plus b is equal to 2, and b plus c is equal to 1, and c plus a is equal to 5. Okay, and if you just add them together and divide by 2, you'll get that a plus b plus c is equal to 8 over 2. That's equal to 4. Now from here, dot, a plus b, c plus b plus c is equal to 1, right? B plus is equal to 1, so a is equal to 3. And if a is equal to 3, b is equal to -1. If b is equal to -1, c is equal to 2. So these are the solutions of this equation. Gabriel, actually our time is up. Thank you very much. Have a good weekend. Okay, I will see you next week. I'll finish here. All right. Bye-bye. See you next Sunday.